In this video, we're going to have a look at the use of image transforms within Android. So it follows on from the earlier lecture. We'll have a look at how we can do things like take an image and draw it out with a varied alpha value, to draw it out, rotate it about a certain point, to draw it out scaled, or to sort of combine different elements together. And we'll use that to provide a number of different visual effects. So the particular demo that we're interested in here is part of the graphics package, then the bitmap test fragment. So this one, I'll show the thing running now, but it contains illustrations of these different types. So if I do fire that off, and we'll be able to see how the thing looks. Inside this demo, there's actually going to be two different ways that we transform objects. One, there will be the draw bitmap method, which provides quite a wide range of different options that enables us to determine how we draw the bitmap out. And the second one then will be the use of matrices. And I'll show you both of them, and you can then see how they do. So bitmap test is the one that we will trigger up. So in this case, we'll sort of do a compare and contrast with the code as we go through this. So you can see we have, it is basically one image, the one shown at the top left-hand corner of the screen, that we're drawing out in different ways. So we'll have a look at each of those as we go through. So bitmap test fragment is the class we're interested in. The onCreate view for this returns a new render view. So this is going to be a remarkably simple renderer for that particular window, but effectively we're getting access to the whole window, and we're then determining what we're drawing to it. In this case, it's the same image drawn with different transformations. So here's our RenderView class. It's a type of view. Inside this we have one loaded bitmap. That's the one bitmap that we're manipulating. We will also have a paint instant that we will use to determine or to control things like alpha value. So when we're painting it out, we can change the alpha value using that. We will have a couple of rectangles, a source and a destination rectangle, and they will help determine which region of the source we draw and the destination on the screen where we draw it to. And we have a matrix that we will use to transform different combinations. Now, in all cases, I'm declaring these things up front, so as part of the RenderView class, because these are objects. So these are rectangles, and this is a matrix object. We will be drawing this out frequently, so we're going to go around and draw and draw and draw. The one thing we don't want to do is to, every single time we come around to draw it, to create new rectangles and to create new matrices, because that results in object creation, which are only used for a few milliseconds and then they're all deleted again. So we want to create them up front once, and then to reuse those objects every single time we draw it out. So it cuts down a bit on object churn. The animation you see down at the bottom of the screen with the rotating and sort of moving and zooming in and out image, it will be controlled by a number of properties. We'll have one for scale, we'll have one for rotation, we'll have one for an offset that we're displaying it at, and then a scale direction if we're making it bigger or making it smaller. So there'll be simply properties for managing that. Here's the constructor. So the constructor of the view object, it creates a new paint, simply a default one, and then it goes to our asset manager and tries to load in the particular bitmap that is displayed on the screen. And our bitmap factory is the one that will try to attempt to load that image in. So if the constructor works, and IO exception means it could be problematic, but if it works, at the end of that we will have a paint and we've loaded in our bitmap. Now, what do we have? We have an OnDraw method. So this extends view. It's a type of view, which means that it will be asked to draw itself. So when it's asked to draw itself, the OnDraw method gets to be called. Now, initially, whenever we're constructing our fragment and we say that the fragment's onCreate view, we return this object. what that will result then is the user interface thread going to the view object and saying to itself, okay, you've been added this fragment, please draw yourself. So this method will be called automatically for us the first time we're at it. What we get provided with is a canvas object. And the canvas object is what we can use to determine how we draw ourselves. I want to briefly just zoom down to the end of this. So at the very end, because we want to repeat this, so we want to have it as basically an animation that keeps on happening, we do two things. So once we've done all of our drawing, we're going to go to sleep for 50 milliseconds. And then we're going to call invalidate. So invalidate basically means I need to be redrawn. So we've set this up so that I will be asked to draw myself. I will draw some stuff. I'll go to sleep for 50 milliseconds, and then I'm going to indicate back to the user interface thread, hey, by the way, you need to call me again. I've invalidated myself. So basically we have a continuous loop there. We will always draw, wait a bit, and then ask to be called again, and the user interface thread will duly call us again. Okay, so that gives you the, if you like, the dynamic bit where it's continually animating. Now, what do we have within this here? So the first one is we're just using the draw bitmap image, where we're specifying image, the X and the Y location, and then how we're drawing it out. And that gives us, if I can shift these things about ever so slightly, that gives us the image at the top left-hand corner of the screen. Now, the 50-50, remember for a graphics device, 0, 0 is the top left-hand side. And anytime we draw out a rectangle and specify its location, we're specifying the top left-hand corner of the rectangle where we want to draw it from. So the top left-hand corner of the rectangle you see at the top left-hand side of the screen is 50 pixels in, 50 pixels down, because that's what the location we specified it at. And that is our default image. That's what it looks like. Next bit after this then, we have drawing a bitmap with the specified alpha multiplier, so we can render things in and out. So to do this, we're going to our paint object, and we're giving it an alpha value of 50%, 128 out of 255. And we're then drawing out our bitmaps, exact same thing as before. This case, one is drawn at X position 200, then Y position 50, and 245 and 70. And we're passing in the paint that has this set alpha value. So it'll draw it out with an alpha value of 50%. Now, importantly, very importantly, we have to remember to reset it. If we didn't reset it, then we would be carrying on using a paint object, which will apply 50% alpha to it. So we probably don't want that. So this then gives us the two faded squares up towards the top of the screen, where we're drawing out again the same image, 50% alpha, and you can see with the overdraw that you get to see through to the one underneath. The next bit we have in this then is draw the specified portion of the image at the specified location, potentially scaled. So they're commonly used to extract a portion of the sprite sheet. Now, what does this mean? If we go back and we have a look at the images here, you'll see that there's two small squares in the top middle of the screen. Now, what we haven't done there is we haven't taken our base image and shrunk it down, because you can see with the empty bar in the middle of the images that it hasn't shrunk in the two smaller ones. So in drawing this out, we've gone to our source image and we said, I only want to draw out a portion of the source image, and it was a little square in the middle of the source image. And I'm saying where I want to draw it out. You'll also notice here that when you look at the two small images, in the one on the left-hand side, you have blue going across to a reddish color, and then the one on the right-hand side, you have red going across to a bluish color. So they have been flipped on the x-axis. And this is what we'll do for animation. We'll have a sprite sheet. There will be lots of different frames of animation in that sprite sheet. So we will want to say we want to draw that particular frame from the overall sprite sheet. And it might show, for example, the character animated as walking, say, to the right. If we want the character to be animated in the opposite direction, then we will flip that image around when we draw it out. And that's really what's simulated in those two draw requests there. We're drawing a small portion of our source image, and in one case we're flipping it around so that it looks to be left to right as opposed to right to left. How do we do this? We're setting up our source rectangle. The original image is 100 pixels wide by 100 pixels deep. So this is picking a 25-25 to 75-75, a 50-50 region in the middle of the image. And we're setting up our destination location. So this is 400 by 50 by 450 by 100. So again, that's a 50 by 50 region on screen. And we draw the thing out. So our source image, source destination rectangle, and the paint, which we reset the alpha back to 255. Now we're going to do exactly the same, but we're going to flip it now. So we change the location to be a little bit further along, so we're not doing them one on top of one another. And you can see here in the destination, if you sort of draw these things out on a piece of paper, we're going from 47550 to 525-100. That we'll specify the destination rectangle, and for the source one, you can see there, if we compare the two source ones, there it was 25-25 to 75-75. This is 75-25 to 25-75. So it looks a bit strange, but if you draw that out on a piece of paper, you realize that you're drawing the rectangle almost to the right to the left, as opposed to left to the right. That's the bit that does the flipping. And again, we talked more about that in the lecture when we had a look at transformations. And that's really the key things that we're interested in if we're going to be using the draw bitmap methods and the different parameters we have in that. The rest of the demo then shows how we can use a matrix to draw these things out in different ways. And the first thing is we're going to use a matrix to scale the image. We're scaling it 50% in the X and 50% in the Y. Now, because at the very top we declared a matrix object, and we're not creating a new one because that introduced garbage churn, we want to reuse the same matrix object. So it's important that we reset it anytime we want to use it. It's basically put it back to an identity matrix, so it doesn't change anything. If we didn't do that, it would remember the old transformation, then add on the new one, and it would get confusing. So anytime I want to use my matrix, I'm going to reset it, which puts it back to the identity matrix, doesn't change anything. And then setting a scaling. So a matrix has a number of different values. Set scales 1, and I'm saying 0.5 in the X and 0.5 in the Y, so that's 50%. I then want to position the thing that I'm drawing at a certain position on screen. And I use the translate method. And I'm saying translate it 50 along the X, 200 along the Y. Now, I'll just show you some of the, so metrics, you have a range of methods here. You can see that, for example, there is post-rotate, post-scale. There's also pre-rotate, pre-scale, and pre-translate. And they're actually down at the bottom, there will also be set translate as well. So these different things come into how you combine matrices together. The important thing to remember about matrices is that they're not commutative in the sense that 3 times 4 is the same as 4 times 3. So multiplication of numbers doesn't matter the order in which you do it. For matrices, it does matter if the order in which you do it. That if I have one matrix transform, for example, a scaling and a translation, the order in which I do these things actually makes a difference. So the set scaling, I use a set for the first transformation I want to do for the matrix. So I reset it, I set a scaling as my first transformation, and then I'm saying after I have scaled it, I do a post. I do this afterwards. I then want to translate it by 50 to be 200. Now I could use the pre if I wanted to say before you scale it, move it first of all, but generally it's good to get in your head the notion of you reset it, you set the first transformation, and then for any transformations you want to apply after that, you do them in order, but you do them as post this or post that. And that'll keep you in the straight and narrow on this case. And there's an example at the bottom where we talk about it a little bit more. Having done that, I then go to my canvas and I want to draw a bitmap. I say, here's the bitmap. And I say, here is the transformation that I want to apply to that bitmap. And there's the paint that I'm using. So in this one, back to our demo here, it is on the top left, we have our default rectangle. And just under that, on the left-hand side, we have a smaller 50 by 50. That is actually scaled by 50% because you look at the bar in the middle of it, it's smaller than the white bar at the top. So we've used a matrix then to shrink that down. We could have used source and destination rectangle, where destination rectangle is 50% the size of the current normal destination, which would have done the same effect. We're also doing that then, drawing it out with a scaling along the X and the Y. Similar process, we reset it, then we do our scaling, then we translate it out, and that gives us the larger square that you see next to the smaller square. So there we have taken our source image and made it bigger. Now, the next things we see are rotations, and we'll look at them first of all on the screen. So to the right of the big square, we have a total of 6 images, 2 sets of 3 rotated images. For the first set of 3, they are when you rotate something, you rotate it about a point by a certain amount. So they are rotated about the box's top left-hand corner. So that's the point that remains invariant. We, if you like, put a pin in there and we rotate it around that point by a certain number of degrees each time. The rotated example then to the far right, in this case, the point that we rotated around is the center of the image. So we basically fixed the center of the image and we're rotating the image around that center. So that's important because when you rotate something, you need to say by how much and around which point. Over here in the code then, we can see how we do this. We reset our matrix. We set how much we want to rotate it, 15. Now, you need to be, first thing we'd ask there, 15 watt. Normally in mathematics, radians is what you would actually use. In Android, when you're dealing with matrices or things like this, they actually use degrees. So it's 15 degrees. It makes it easier, I suppose, for, I don't know, your general programmers to understand it. But strictly speaking, if you've been doing a lot of rotation or MAS before, you're probably more used to thinking in radians. But anyway, this is 15 degrees. Now, it's plus 15 as opposed to negative 15. So positive rotation is in a clockwise direction. So this basically says rotate the image by 15 degrees in a clockwise direction. We translate it, draw it to a certain position, and we draw out that bitmap. Then we reset it. We now do a rotation of 30 degrees, translate it, and draw the thing out. Now, if we didn't reset that, and I then did set rotation, it's going to be building on or adding on to these things. Reset it again, I do a rotation of 45 degrees and give its output location. So you can see in all cases the output location here is the same. So the top left-hand corner of the box doesn't change, that's where we draw it out, but we just draw it out, rotate it around that point by 15, 30 or 45 degrees. So if we don't specify a point, it assumes it's 0, 0 is the point of rotation, and by default in the box that is the top left-hand corner. What we have underneath then is where we want to rotate about the center of the box. And for most of the things that you'll do within games, if you do have rotating objects, it'll probably be about the center of the object. So what you're seeing on the screen now is a little bit more common. So in this case, we're setting our matrix. We are rotating 15 degrees in a positive clockwise direction about the point 50-50. Now this is 50-50 relative to the image, the bitmap itself, and this is a 100 by 100 bitmap, so 50-50 actually corresponds to the center point of the bitmap. Then we do our translation, we move it somewhere on screen, paint the thing out. Then we reset it. We set a rotation this time 30 degrees in a clockwise direction, again around the center of the image. Translate it to the same location as before and draw the thing out. And ditto for the fourth one. So it gives us our rotated image about the center. Nearly there. So skewing is the last thing. Don't often use skewing. You might have it for some special effects. You want to sort of generate a shimmering effect. So the skewed one is so this if you like, it was a rectangle. It had an X and Y. There was a 90 degrees to one another. If we skew it, we bend the sides of it. Still keeping the sides parallel, but where it was 90 degrees, we're changing that angle, making it skew. So quite easy to do. We can reset our matrix. set up the skew along the X and the Y axes. So this time it's 0.1 and 0.2 along those axes. Move it, draw the thing out, and you get what is displayed there. Now the thing at the bottom is, I think, the thing that's more interesting. So this is the thing that is moving and changing and interacting. And if you are using transforms within a game, it's because you probably want things to be fading in and fading out, to be shrinking and growing, to be rotating and otherwise moving. We use it not to do fixed static effects like you see in the top of the screen, but to do dynamic changing effects like you see in the bottom. And that's where the real power of matrices comes in. Now, you can combine all of these things into a single matrix. I can take something, I can move it about, I can scale it, I can rotate it, all embedded or encapsulated in a single matrix. If I'm doing that, it is important to build up the matrix in the right order in a way that actually will consistently give me what I want by way of output. And there's a small mnemonic, the ISROT mnemonic, where you start off with the identity matrix. So in other words, you reset your matrix. You then scale. So if you have to do a rotation, a scale, and orbit, those types of things, you initially start off with a blank matrix. First thing you do is you scale it. That should be the first operation that you do. Then, if you need to rotate it about the center of the object, and only about the center of the object, do that next. So if it's rotation about the center, that's what you should do after you've scaled it. And then you have the O stands for orbit, that other than rotating about the center of the object, if you want to rotate about some other point in your world, you do orbit next. So you let the object rotate about its center, and then you let it rotate about any other point. And often you don't orbit, but if you do, that's when you would do it. And the very last thing you do is you translate. So you do all of these operations, and then you move it to the location where you want it displayed in the world. And as long as we stick to that ordering, then things will hang together. If you don't stick to that ordering, they probably won't hang together. So what do we have there? We have a bunch of code that, for example, changes the scale value, and depending if we're scaling up or scaling down, it'll either make it shrink or grow. We have an offset as well for our rotation. We're always changing that by 0.2. So again, we're just simply modifying these values so they go up and down between ranges, and that's going to give us the visual appearance we see on the screen. The actual draw magic, I suppose, happens down here. We reset our matrix, then we scale first of all. So in this case, we're scaling it by whatever number we have. Then we rotate about its center next of all. So it's still the 100 by 100 image. So we are rotating about the 50-50 point, the middle of the image. If we did have an orbit, if we wanted to rotate about some other point, then we would do that there. I'm not doing it in this case. And finally, we move it to where we want it displayed in the world. And then again, fixed X location plus some offset, and then always staying at position 700 along the Y. And we draw out the canvas object, and that's it. And that gives us our moving, rotating, offset, scaled object appearing on screen. Now that's all we want to cover within this particular one. The basic setup is actually reasonably straightforward. It is incredibly powerful in terms of what you can use these things for. One final thing I will mention, because quite a lot of students sort of come across this. At the top, we were using the draw bitmap methods, and you could specify a region, a bit of the bitmap that you wanted to draw out. And we said that that was particularly good if you had an animation and you wanted to draw out one frame of that animation. Anytime we were drawing out using the matrix, we actually applied the matrix to the whole image, not a region of that image. So that's an important thing to bear in mind, that when you are using the matrix, it will apply to the whole image. And you have to do a little bit extra work if you just want to take a region of the image in terms of clipping the thing out and applying your matrix transformations to just that. But lots of things here you can do by way of adding in nice visual effects for your particular game development.